Now, this is exactly what I was talking about. If we go back to the keynote, things you might see in Colab, this is one of them. So what it means is that I took a little break just now, and if we come back to Colab, because of the limited amount of resources that Google is able to provide, if you leave your notebook in Colab for a long enough time, it will eventually disconnect from a runtime, which is a runtime is again just a computer on Google's server that powers your notebook. So this is what you do if you have to take a break, and you should take a break every so often. You're not spending too much time sitting down. Go for a walk. Nature's beautiful, right? Well, that's what I just did. I just took my dogs for a walk. So if you do get this little pop-up, you're going to have to reconnect, but you'll see up here, the runtime is reconnecting. So it's initializing, mounting Google Drive, which is where our files are. Maybe it takes a little while to appear. There we go, Drive. We'll have Google Drive back. There's Dog Vision, our beautiful little project folder. Excellent, we can close this up, we don't need that. But what we're going to have to do is, I better tick off these, right? Pay attention to my own notes. I'll put a little green tick emoji. We've imported TensorFlow Hub, making sure we're using a GPU. Now, the beautiful thing is, the notebook itself will save the fact that we are using a GPU. So when it reloads, we won't have to change the hardware accelerator to GPU. It will automatically load it as a GPU. But we do have to rerun any cells that we may have ran before. So there we go. Check for GPU, import TensorFlow, make sure we're using TensorFlow 2.x. And I'll delete this one. Wonderful. Okay, so now we've got our workspace ready. And you might be thinking, Daniel, that took a fairly long time to get set up, but as always, a person is only as good as the tool they use, right? Or as the tools they use. So that's why we spent a bit of time getting our Colab workspace ready, getting our new project folder together, getting our data there. So now, if we go back, what step are we up to? There should be a 0 here for getting our workspace ready. But now we're up to step 1, which is getting our data ready, aka turning it into tensors. Now, this is the premise of TensorFlow in itself. That's why it's called TensorFlow. The premise is to get your data into tensors, aka, remember, all machine learning models like to deal with numbers. So we have to get our data into tensors, which is just a fancy word for matrix, aka a NumPy array with some dimensions. But a tensor, the key thing here is that it can be run on a GPU. So if we go back here, TensorFlow is turn your data into tensors, and then it flows through a workflow like this. You get it? TensorFlow? Who knew? Doing a machine learning course and you get a comedy show for free. All right. So step 1, we're going to access the data. So right now it's over here in Drive, in the Dog Vision. So now we have to somehow get it from this folder into this code space. So let's do that. We'll get out of that. We'll make a little heading. Actually, we can go to here, getting our data ready, turning it into tensors. Remember, we're communicating with ourselves here. We go here with all machine learning models. Our data has to be in numerical format. So that's what we'll be doing first. Turning our images into tensors. Numerical representation. Okay. Now, this is a code cell, and in Colab, a special way to transform something into Markdown is to hold Command and double tap M. If you want to see a list of all shortcuts in Colab, hold Command MH. There we go, have a look at that. Far out. There's a lot there. So this takes some practice, again, because some of the commands we've been using in Jupyter are slightly different. If you do need to look one up, have a look in here. Otherwise, I'll just kind of keep running with it. If I need to add a code cell, I can just press this little plus button here or up here. And the main one we'll be using is Shift and Enter, right? Just to run our code. Let's check out the labels. What does that look like? So if we come back, let's start by accessing our data and checking out the labels. So to do that, it's in a CSV format. So if we want to check it out, we might have to, or we will have to import pandas, because it's a lot easier to look at things that are CSV format using pandas. So check out the labels of our data. We're going to import pandas as PD, our favorite. Labels CSV equals. So what we're going to do is just pass in, maybe we could set up a little path, but we'll type it out to begin with. We could just copy this, copy path, but we're going to practice. What would that look like? Something like that. Let's practice typing it out. Remember, you don't need content. Drive, my drive, /dog vision. Oh yeah. This is what projects need, right? They need cool names. Labels.csv. All right, and we're going to can that. And then what we might check out is we'll get label CSV. We wanted to describe it. .describe would help if I could type. Fourth time lucky. There we go. And print. We'll also get the head, so the first 5 rows. Let's check it out. Again, we'll remove this, more space. Wonderful. What do we have here? Count. 10,222 ID, breed, 10,222 unique values. So, okay. So there's 10,222 unique IDs and 120 unique breeds. And then this is what the ID column looks like. Again, it looks a bit different because we've printed it. So if we just did labels.csv.head, this is what you might be used to looking at, something like that. There we go. So we've got an ID column, which is the file names, I believe, of our images. So this is of train and the breed associated with that ID. Now, a little tidbit here. If you do have a lot of files in one of your folders in Google Drive, it actually does take a fairly long time to load here. So rather than wait for that, let's just go back to Kaggle. We'll treat this as our way of looking at things. There we go. So if we go to label CSV, 10,222 unique values. Yes, that's correct here, unique. And then train, we've got unique ID. So does that look like what we've got in ID? Yes, it does. Wonderful. Okay, now what we might check out, we got 120 different breeds. So that means that there's 10,000 or so images. Hopefully, there's about 100 or so images per class. Well, actually, let's just figure that out. Let's figure out how many images there are per class first, and then we'll see why that's important. How many images are there of each breed? And we could probably do this pretty easily by going labels, CSV, breed. So I'm accessing the breed column. And then I'm going to go value counts. So count the values in this column. Actually, let's just see what that does. This is a dog breed, Scottish Deerhound, Maltese dog, Entel Butcher. Not even sure what that is. Shout out if your dog's on here. Eskimo dog. Yeah, that's really cool. Okay, and now let's visualize this. It's probably going to look a bit better if we visualize this. Fig size equals 2010. Whoa. See, the beauty of Colab is that we didn't even have to import matplotlib to see that. So my notebook's a bit zoomed in, but this is pretty cool. If we were to draw a line, so look, we've got dog breeds here, all of our 120 different dog breeds, and then this is the number of images that they have. So if we were to draw a line somewhere across here, we'd say about maybe 75 on average. We can figure that out pretty easily anyway. So labels, CSV, how do you find the mean of a column? Actually, we need to count them first, because otherwise they're just strings. Dot mean. Average. Median's probably a little bit more robust than the mean. So the middle number, 82. Okay, so we said 75. But that is a good thing. You could imagine, right? If you had, let's say, Scottish Deerhound, if we had 500 images of that, but this bad boy over here, what is this one? Eskimo dog. If we only had 3 images of Eskimo dog, we could imagine our machine learning model might do very well at figuring out what a Scottish Deerhound looks like because it has so many examples. But as for an Eskimo dog, if there's only 3 images, it's probably going to be a bit hard to figure out what it looks like. When you're asking yourself how many images should I have per class, Google recommends a bare minimum 10. Google minimum number of images per class. Preparing your training data. Here we go. So this is Google's AutoML, so which is their service for automatically building machine learning models. This is some extracurricular if you want to check this out. It's pretty cool. Preparing your data. There we go. For model training purposes, it is recommended you use about 100 annotations per label. So in our case, it would be great if you had 100 examples of each image class with at least 10. So 100 is great, but at least 10 is a good start. So if you wanted to build your own image classifier, if it's a binary classification, you'd want to be looking at minimum 10 images per class. So our data set at about 75 to 85 images per class is pretty well spread out. This is a good start. Okay, so I've done a little bit of exploration of the labels. Now, what we might do is start to get our image paths. So labels is pretty easy to deal with in a CSV, but all of our images, again, we can't see that, are in this format here. So we need a way to get them into our Colab notebook. Let's have a look at how to do that in the next video.